Hello and welcome to this video on procedural statements and control flow in SystemVerilog. In this video, we will cover a range of topics related to procedural statements and control flow in SystemVerilog. We will explore these concepts in depth and provide examples to help you better understand how they work in practice. So, buckle up and get ready to learn some exciting stuff about SystemVerilog, procedural statements and control flow. Don't forget to like and subscribe to our channel for more informative videos like this. So, let's dive in. Here is an overview of the topics we will be covering. First, we will cover the basics of blocking and non-blocking assignments and how they are used in SystemVerilog. Next, we will dive into loop statements, including the while loop, do-while loop, foreach loop, for loop, repeat loop, and forever loop. We will discuss when each of these loops is appropriate and provide examples of how to use them. Finally, we will discuss jump statements, including break and continue. These statements allow us to change the order in which statements are executed and exit loops prematurely. By the end of this video, you'll have a solid understanding of procedural statements and control flow in SystemVerilog and be able to use them effectively in your own digital hardware designs. So, let's get started. Let's start with the blocking assignments. Definition. A SystemVerilog blocking assignment is an assignment statement that executes in a series order, blocking the execution of the next statement until the completion of the current assignment execution. These assignments are made using the = operator and are executed one after the other in a procedural block. Let's break this down a little further. When a SystemVerilog blocking assignment is encountered, the program will pause the execution of the next statement until the current assignment is complete. This ensures that the program executes each statement in the order they appear in the code. However, it's important to note that this won't prevent the execution of statements that run in a parallel block. Here is an example to help illustrate this concept. Always at posage CLK begin. A is equal to B. C is equal to D. End. In this code, we have an always block that is triggered on the positive edge of the CLK signal. Inside the block, we have two SystemVerilog blocking assignments, A is equal to B and C is equal to D. The program will execute the A is equal to B assignment first, and then move on to the C is equal to D assignment only after the A is equal to B assignment is complete. So that's a basic overview of SystemVerilog blocking assignments. They are a simple but important concept in digital design that ensures the program executes each statement in the order they appear in the code. Now, we will discuss a code example that demonstrates the use of blocking assignments in SystemVerilog. Let's begin by taking a look at the code for this module called blocking_assignment. The module declares two integer variables called var1 and var2. It also defines an initial block that runs at the beginning of the simulation. Inside the initial block, the module displays a separator line to make the output easier to read. It initializes the values of var1 and var2 to 10 and 15 respectively. The initial values of var1 and var2 are then displayed using the $display function. The module then uses a blocking assignment to assign the value of var2 to var1. This means that the value of var1 will be immediately updated to the value of var2. Next, a blocking assignment is used to assign the value of 20 to var2. Finally, the module displays the final values of var1 and var2 using the $display function. Another separator line is displayed to make the output easier to read. Now let's take a look at the output of this module. Before the assignments, the value of var1 is 10 and the value of var2 is 15. After the assignments, the value of var1 is 15 and the value of var2 is 20. This is because the first assignment using a blocking assignment assigns the value of var2 to var1. Since it is a blocking assignment, the value of var1 is immediately updated to the value of var2. This means that after this assignment, both var1 and var2 have the value of 15. The second assignment using a blocking assignment assigns the value of 20 to var2. Since it is also a blocking assignment, the value of var2 is immediately updated to 20. This means that after this assignment, var1 still has the value of 15 and var2 has the value of 20. Now let's look at the non-blocking assignment. Definition. Non-blocking assignment statements allow multiple assignments to occur in parallel without blocking the execution of following statements. This means that all the assignments will occur at the same time during the end of simulation timestamp. Non-blocking assignment statements are specified using the less than or equal to symbol. It's interesting to note that this symbol is also used as a relational operator in expressions. Here is an example to help illustrate this concept. Consider the following code snippet. Always at posage of clock, begin. A less than or equal to B. C less than or equal to D. End. This is an always block with two non-blocking assignments inside it. The block is triggered on the positive edge of the clock signal, posage CLK. Now, let's take a closer look at how execution happens in non-blocking assignments. When the always block is triggered, the first non-blocking assignment less than or equal to is scheduled to happen at the end of the time step. This means that the value of B is not immediately assigned to A. Instead, the assignment is added to a queue and is scheduled to happen at the end of the time step. The same is true for the second non-blocking assignment less than or equal to. It is also added to the queue and scheduled to happen at the end of the time step. Once all the statements in the always block have been executed, the non-blocking assignments in the queue are executed in parallel. This means that the assignments to A and C happen at the same time without blocking the execution of following statements. It's important to note that the order of the assignments inside the always block does not matter. In this example, we could have swapped the positions of the less than or equal to and less than or equal to assignments, and the result would have been the same. To summarize, execution in non-blocking assignments works by scheduling assignments to happen at the end of the time step without blocking the execution of following statements. The assignments are executed in parallel, regardless of their order in the code. Now, we will discuss a code example that demonstrates the use of blocking assignments in SystemVerilog. Let's start with the code. Here we have a module called non-blocking_assignment, which has two variables x and y of type integer. We have an initial block that initializes the variables x and y to 10 and 15 respectively. Then we display the initial values of x and y using $display. Next, we have two non-blocking assignments. The first non-blocking assignment is x less than equal to y, and the second non-blocking assignment is y less than equal to 20. Note that we have used a delay of number 1 between these two assignments. This means that the second assignment will happen one time unit after the first assignment. After the assignments, we display the final values of X and Y using $display. Finally, we have a final block that displays the end of simulation values of X and Y using $display. Now, let's take a look at the output of the simulation. We can see that the initial values of X and Y are 10 and 15 respectively. After the two non-blocking assignments, the value of X becomes 15, which is the value of Y at the time of the assignment. However, the value of Y remains the same at 15, as the second assignment to Y happens only one time unit after the first assignment. In the end of simulation, we can see that the value of X is still 15, which was set by the first non-blocking assignment. However, the value of Y has been updated to 20 by the second non-blocking assignment. So, we can see that non-blocking assignments allow multiple assignments to happen concurrently and independently of each other. This is because non-blocking assignments are evaluated at the end of a time step after all other statements in the procedural block have been evaluated. Now, we will see the difference between blocking and non-blocking assignments. In SystemVerilog, a blocking assignment is executed immediately, and the next statement will not execute until the current statement is completed. On the other hand, a non-blocking assignment is executed in parallel with other statements, and the next statement will start executing immediately, regardless of whether the current statement is completed or not. To understand the difference between the two, let's take an example. Suppose we have two variables, A and B, both initialized to 0. We want to perform the following operations: set A to B plus 1 and set B to A plus 1. First, we will implement this using blocking assignments. In this case, we will initialize A and B, and then perform the operations using blocking assignments. Finally, we will display the final values of A and B. After executing the code, we get the output as follows: value of A is 1 and value of B is 2. Now, let's implement the same operations using non-blocking assignments. In this case, we will initialize A and B, and then perform the operations using non-blocking assignments. Finally, we will display the final values of A and B. After executing the code, we get the output as follows: value of A is 0 and value of B is 0. As you can see, the outputs of the two examples are different. This is because in the second example, we used non-blocking assignments, which execute in parallel with other statements. This means that when A is set to be plus 1, B has not yet been updated to its new value, so A is set to 0 plus 1, which is still 1. Similarly, when B is set to A plus 1, A has not yet been updated to its new value, so B is set to 0 plus 1, which is 1. To summarize, blocking assignments execute immediately, while non-blocking assignments execute in parallel with other statements. It's important to understand this difference in order to write correct and efficient SystemVerilog code. Now, we will take a look at loop statements. Loop statements are used to execute a block of code repeatedly until a certain condition is met. They are very useful when you want to perform a certain action multiple times without having to write the same code over and over again. Let's take a look at some of the loop statements that are available in SystemVerilog. While loop. The while loop in SystemVerilog is used to execute a block of code repeatedly while a specific condition is true. The loop will continue to execute until the condition becomes false. Here is an example of the syntax for a while loop in SystemVerilog. While condition. Code to be executed. Let's break this down. The keyword while is followed by a condition in parentheses. This condition is checked before each iteration of the loop to determine whether the loop should continue or terminate. The block of code to be executed is placed immediately after the condition within curly braces. Here is an example of how this loop might look in practice. In this example, the loop will execute as long as the condition counter 5 is true. The loop will continue to execute until the condition becomes false, at which point it will terminate. Here is a syntax flow diagram for a while loop. The flow diagram starts with the start block, which represents the beginning of the loop. The loop will then move to the check condition block, where the condition specified in the while statement will be evaluated. If the condition is false, the loop will exit and move to the end of loop block. However, if the condition is true, the loop will continue executing and move to the execute block of code block. This block represents the block of code that is executed as long as the condition is true. After executing the block of code, the loop will move back to the check condition block to reevaluate the condition. This process will continue until the condition becomes false, at which point the loop will exit and move to the end of loop block. Do-while loop. The do-while loop in SystemVerilog is used to execute a block of code repeatedly until a specific condition is met. This type of loop is similar to the while loop, but with one key difference. In a do-while loop, the block of code is executed at least once, regardless of whether the condition is true or false. Here is an example of the syntax for a do-while loop in SystemVerilog. Do. Code to be executed. While condition. Let's break this down. The keyword do marks the beginning of the loop. The block of code to be executed is placed immediately after the do keyword within curly braces. The keyword while is followed by a condition in parentheses. This condition is checked after each iteration of the loop to determine whether the loop should continue or terminate. A semicolon marks the end of the do-while loop. Here is an example of how this loop might look in practice. In this example, the loop will execute at least once, because the condition counter 5 is only checked after the first iteration of the loop. The loop will continue to execute until the condition is false, at which point it will terminate. Here is a syntax flow diagram for a do-while loop. The loop starts with the start box. The program will then move to the execute block of code box and execute the code within the loop at least once. Once the code has been executed, the program will move to the check condition box and evaluate the condition specified in the do-while loop. If the condition is true, the program will move back to the execute block of code box and execute the code within the loop again. This process will continue until the condition becomes false, at which point the program will move to the end of the loop and continue executing the remaining code. One important difference to note between the while and do-while loops is that the do-while loop guarantees that the block of code will be executed at least once, regardless of the initial value of the condition. I hope this helps you understand the syntax flow diagram for a do-while loop in SystemVerilog. Now, we will talk about the forage loop in SystemVerilog. The forage loop is a powerful construct in SystemVerilog that simplifies the process of iterating over elements in an array. It eliminates the need for index variables and can be used with both single and multidimensional arrays. Let's look at the syntax for the forage loop in SystemVerilog is foreach, variable, iterator, begin. Statements to be executed for each element. End. The variable is the name of the loop variable used to reference the individual elements of the array. The iterator is the name of the array or list over which the loop will iterate. The number of loop variables must match the dimensions of the array or list. Let's see how to use the forage loop in SystemVerilog with some examples. First, we will look at an example of a single-dimensional array. In this example, we create an integer array A with 4 elements and use the forage loop to iterate over each element. In the forage loop, we use the variable A, I, to reference each element of the array, where I is the loop variable. Within the loop, we set the value of each element of the array equal to the loop variable I. We then use another forage loop to print out the value of each element of the array using the $display SystemVerilog task. When we run the code, we see the output. Value of A, 0, is equal to 0. Value of A, 1, is equal to 1. Value of A, 2, is equal to 2. Value of A, 3, is equal to 3. Next, let's look at an example of a multidimensional array. In this example, we create an array A with 3 rows and 2 columns and use the forage loop to iterate over each element. In this forage loop, we use the variable A, I, J to reference each element of the multidimensional array, where I and J are the loop variables. Within the loop, we set the value of each element of the array equal to the sum of the loop variables I and J. We then use another forage loop to print out the value of each element of the array. When we run the code, we see the output. Value of A, 0, 0, is equal to 0. Value of A, 0, 1, is equal to 1. Value of A, 1, 0, is equal to 1. Value of A, 1, 1, is equal to 2. Value of A, 2, 0, is equal to 2. Value of A, 2, 1, is equal to 3. The forage loop in SystemVerilog is a powerful and versatile construct that can be used to iterate over elements in both single and multidimensional arrays. It eliminates the need for index variables and simplifies the syntax, making code more readable and maintainable. Let's start with the for loop. The for loop is a control statement that is used to execute a set of statements repeatedly based on a specified condition. In Verilog, the for loop has some limitations. The control variable of the loop must be declared before the loop, and it allows only a single initial declaration and single-step assignment within the for loop. However, in SystemVerilog, the for loop is enhanced and allows for more flexibility. Let's take a look at the syntax of the SystemVerilog for loop. For initialization, condition, modifier, begin. Statement 1. Statement n. End. The for loop syntax consists of 3 parts. Initialization, executed first and only once. This allows the user to declare and initialize loop control variables. Condition, the condition is evaluated. If it is true, the body of the loop is executed, else the flow jumps to the statement after the for loop. Modifier, at the end of each iteration, it will be executed and execution moves to the condition. Now, let's take a look at an example of the SystemVerilog for loop. In this example, we will declare a loop variable I within the for loop and print its value. As you can see, we have declared the loop variable I inside the for loop and initialized it to 0. Then, we have specified the condition to execute the loop while the value of I is less than 5. Inside the loop, we have displayed the value of I using the $display statement. Finally, the loop ends after the value of I reaches 5. Value of I is equal to 0. Value of I is equal to 1. Value of I is equal to 2. Value of I is equal to 3. Value of I is equal to 4. The simulator output shows that the loop has executed successfully and printed the value of I from 0 to 4. In SystemVerilog, we can also declare and initialize multiple variables inside the for loop. Let's take a look at an example. In this example, we have declared and initialized two variables, I and j, inside the for loop. We have specified the condition to execute the loop while the value of j is less than 8. Inside the loop, we have compared the values of I and j and displayed a message if they are equal. Value j is equal to 4 equals to value of I is equal to 4. The simulator output shows that the loop has executed successfully and printed a message when the values of I and j are equal. Similarly, we can also use multiple modifiers inside the for loop. Let's take a look at another example. In this example, we have used two modifiers, j++ and I-, inside the for loop. We have initialized j to 0 and I to 7. We have specified the condition to execute the loop while the value of j is less than 8. Inside the loop, we have displayed the values of j and I. Value j equals to value of I, j is equal to 0, I is equal to 7. Value j equals to value of I, j is equal to 1, I is equal to 6. Value j equals to value of I, j is equal to 2, I is equal to 5. Value j equals to value of I, j is equal to 3, I is equal to 4. Value j equals to value of I, j is equal to 4, I is equal to 3. Value j equals to value of I, j is equal to 5, I is equal to 2. Value j equals to value of I, j is equal to 6, I is equal to 1. Value j equals to value of I, j is equal to 7, I is equal to 0. The simulator output shows that the loop has executed successfully and printed the values of j and I in each iteration. Now we will take a look at repeat and forever loop. Firstly, let's discuss the repeat loop. This loop is used to execute a set of statements for a fixed number of times. The syntax of the repeat loop is as follows. Repeat variable begin. Statements end. The loop executes the statements within the block for a number of times specified by the variable. Let's look at an example to understand this better. In this example, we will execute a set of statements 4 times using the repeat loop. Take a look at the example. In this code, the statements inside the repeat block will be executed for 4 times, as specified by the variable 4. The output of this code will display the values of a from 0 to 3. Next, let's talk about the forever loop. As the name suggests, this loop executes the statements within the block indefinitely. The syntax of the forever loop is as follows. Forever begin. Statements end. The loop executes the statements within the block repeatedly without stopping. Let's look at an example to understand this better. In this example, we will execute a set of statements indefinitely using the forever loop. We will look at the example the statements inside the forever block will be executed indefinitely. The output of this code will display the values of A incrementing by 1 after a delay of 5 time units. We have used a delay of 5 time units to avoid an infinite loop and to give us time to stop the simulation. In conclusion, repeat and forever loops are essential constructs in SystemVerilog for executing a set of statements repeatedly. The repeat loop executes statements for a fixed number of times, while the forever loop executes statements indefinitely. Now, we will have a look at jump statements. The jump statements has break and continue statements in SystemVerilog are used to alter the normal flow of control in a loop. They are often used to terminate a loop early or skip over certain iterations of a loop. Here is an explanation of each statement, along with examples. Break statement. The break statement is used to terminate a loop early. When the break statement is encountered within a loop, the loop is immediately terminated and the program continues executing the code that follows the loop. Here is an example of a break statement in a for loop. In this example, the loop will iterate from I is equal to 0 to I is equal to 4, at which point the break statement will be encountered and the loop will terminate early. The output of the program will be I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3. I is equal to 4. Next, we will have a closer look at continue statement. The continue statement is used to skip over certain iterations of a loop. When the continue statement is encountered within a loop, the loop immediately moves on to the next iteration without executing any further code within the loop for the current iteration. Here is an example of a continue statement in a while loop. In this example, the loop will iterate from I is equal to 1 to I is equal to 9, skipping over the even numbers due to the continue statement. The output of the program will be I is equal to 1, I is equal to 3, I is equal to 5, I is equal to 7 and I is equal to 9. I hope this helps you understand the break and continue statements. That's it for our overview of procedural statements and control flow in SystemVerilog. Let's quickly recap the topics we covered. We started by discussing blocking and non-blocking assignments and their usage in SystemVerilog. Next, we covered loop statements, including the while loop, do-while loop, foreach loop, for loop, repeat loop, and forever loop. We looked at when to use each loop and provided examples of how to use them. Finally, we discussed jump statements, including break and continue. These statements allow us to change the flow of execution and exit loops early. Overall, these concepts are fundamental to understanding how to design and verify digital hardware systems in SystemVerilog. By mastering procedural statements and control flow, you'll be well on your way to becoming a proficient SystemVerilog engineer. Thanks for tuning into our video on procedural statements and control flow in SystemVerilog. We hope you found it informative and helpful. If you have any questions or feedback, please feel free to leave a comment below. We love hearing from our viewers and value your input. If you enjoyed this video, please consider giving it a thumbs up and subscribing to our channel. We regularly post videos on digital design and verification, so be sure to stay tuned for more great content. Once again, thank you for watching. This is Zairaj Mirashi signing off, and we will see you in the next video.